everybody. I hope you are enjoying your Pi Day. I'm Am Grabillny, one of the hosts here for AWS OnAir and a dev advocate here at AWS. What an exciting day, Adrian. You are live there in the studio in the future there, right?
In the
Not right
future,
now.
yes. Great things are happening in the future, and I think I'm still a part of it. Hey, everyone. My name is Adrian San Miguel. I'm an enterprise architect here at AWS, and as Ian mentioned, one of your hosts for Pi Day.
We are going to be talking with our friend June here in just a few minutes, and we're going to be talking all about how to optimize your inference, I believe. Let's get June on screen so we can ask him.
Yeah, let's.
Hey, June, welcome.
Hello, my name is June. Thanks for having me here.
Tell us about yourself, June. Introduce
Yeah,
yourself to the audience.
I'm a product manager in SageMaker and Bedrock hosting team. And I'm happy to have the chance to share some of our latest releases that we had at the reInvent. And we've heard a lot about our new feature from our customers, and they really resonated well. So I just wanted to use this opportunity to share with greater audience.
Very nice. Now, June, walk us through, please, if you would. When you're building an application that uses inference, right? That takes a prompt, goes out. What are the ways that you're seeing our customers out there building these types of applications?
Yeah, let me start from services that we provide at the AWS. So AWS provides flexible ways to meet different use cases of our customers, especially in GenAI use cases. And specifically, we have Amazon Bedrock for serverless offering and Amazon AI for solarful inferencing offerings. Depending on the customer's need and total cost of ownership, they choose one or the other for their use cases. Now, one thing that really resonated well with our customers lately is one of the new features that we developed for Amazon SageMaker AI, which allows customers to host multiple variants of a same model within a single instance, which wasn't allowed before. So before, for the same use case, customers had to create like 3 or 5 instances just to do the testings, for example. But then with this feature, they can actually create one instance and be very cost effective when working with multiple variants of a same model.
Actually, I'm going to jump in. Why would a customer want to use more than one model? I mean, I know a lot of folks are fairly divided in the camp, and I kind of know the answer to this already. But for the benefit of folks that may not, why would you want to use more than a single model?
Yeah, there are many different reasons, but let me talk about 3 different use cases that I've seen from our customers. So one is customers may be operating in different regions where there are different languages and there are different terminologies. However, most of the models are trained on more generic terminologies and English-based languages and whatnot. So a lot of customers fine-tune the very strong base model, such as Llama or Qwen, and fine-tune it with different languages so that the model starts to understand the nuance and the specific languages of different locations. That's one use case. The other one is customers might be operating in different business units. So there are specific finance terms that the finance team uses. There might be different terms that sales team is using for sales purposes. But at the same time, the company might not want to expose the terminologies from one team to the other, the information from one to the other. So they want some type of a segregation or isolations across different business units. In those cases, they would fine-tune a base model with different terminologies from different business units and create a 2 separate model. The last use case is when customers are trying with multiple data sets to find which is the best data set that they should be fine-tuning the model with. They may actually create 5 and even tens of variations using different data sets that they have that are tailored in different manner to see which one actually wins in their evaluation score. So those are kind of 3 reasons why they might actually fine-tune a single model, create a different variants of a different model. Now, as you can see, there are a lot of businesses and different languages, so that can lead to a lot of instances that they need to create to do these type of testings.
You got me intrigued now, June. I want to see how you do this. Can we pull up your screen? You told us you have a demo. You're going to show us how to actually use this feature, right?
Yeah,
Okay, let's take a look. I see some terms here that maybe I'm not familiar with. So I see LoRa right up front. Can you tell us a little bit about what that means? What is LoRa? I feel like that's key to what we're about to learn.
yeah. So LoRa and also PEFT is another terminology that is used with the LoRa. Is actually a fine-tuning technique that allows customers to freeze a large portion of the model and then only fine-tune subset of the parameters so that the base core performance of the model stays while the some nuances and specific portion of the models are tweaked with the additional data sets. So this is a very good way to use for different use cases that we just talked about. And one benefit of this is not only it can freeze the core part of the model, but also the fine-tuning speed is much faster than fine-tuning from scratch. So this is a very much widely used technique amongst the customers who have the use cases that we talked about.
Very nice. All right, let's jump in. Let's see how to deploy to this one instance. I assume it's just going to share that base model then, instead of having to redeploy it every single time for every variant. Is that
Yeah,
what's going to happen?
yeah. So I have a little picture that talks about the demo scenario that I came up with. So let's say there's a customer who has three different variant of a same model. And let's say Quinn model, because that's the model that we're going to use for this demo. Previously, customers needed to deploy each of the model variant into three separate instances, and which then costed them three instances of worth of cost. With the PEFT and LoRa support feature that we released on the SageMaker AI, customers can now actually put the same models all in a single instance. Exactly how that works is that the base model is loaded onto the GPU with one LoRa adapter, and then the other two are loaded onto the CPU and disk. And when the inferencing happens for a specific variant model, the system automatically switches what's loaded to the GPU from the location that the appropriate LoRa adapter is stored within CPU and disk. So there's going to be a bit of a delay in at the time of inferencing because of the hot swap, but we can talk about that a little bit later. But we'll talk about the actual way of how to set this up first.
Yeah,
Let's go.
it's interesting you mentioned that because many of the customers and partners I'm talking to, when they're trying to run their own inferencing jobs, they have to reconcile what version do I want? Should I even go in for conversion? And then how do I go get capacity to go do this? It seems like this is really going to help them solve that in a pretty intuitive way.
Exactly. GPU capacity is very much of a scarcity resource across the globe, and this will really help them run efficiently when they have multiple models.
Cool.
All right. So I'm going to talk through how they can actually set up first the base model in an instance, and then add different LoRa adapters on top of it. For any SageMaker endpoints, customers first need to create a model object, and then they need to configure an endpoint, and then eventually create the model endpoint. So let's start with the creation of the model object. The model object requires two information. One is the container information, especially where the container is located, and then the parameters that are going into the container to understand that what type of features are going to be used from that container. Now, in this case, because the feature is something that we developed, we highly encourage customers to use our LMI container, which SageMaker AI team develops and maintains. And in this website, we list different versions and the location of those containers. So customers can just copy paste that information here. Then for the environment variables, there are a couple things to note here. Normally, customers would need to define exactly what model they're going to use and batch size and whatnot. Those are all the normal operations that they need to do. On top of that, to enable the PEFT and LoRa adapter support, they need to enable it. They need to set the environment variable for LoRa as true, They also need to set how many LoRa adapters they want to set on the GPU as well as onto the CPU. This is a trade-off decision where customers can make between adding more adapters into GPU, which will then take out memory space for the models. And those are all the decisions that customers will make in subsequent steps. So for now, for the purpose of demo, I'm going to put one LoRa adapter onto the GPU, and then one CPU, one adapter into the CPU. Now, I said two, but it's actually one because it's actually including the number that's included in the GPU as well. All right, I'm going to register this environment, and then now I'm going to actually create the model object. I defined the model name to be Qwen OnAir for this demo, specified that the image location of this particular model object is located in the URL that we designated above, and then the environment variable that we just set above as well. So if I run this, it takes about a second to create the model object. And if I go to SageMaker Studio, or customer can also visit the Unified Studio as well, and go to Models and Deployable Models, here now we have something called Qwen OnAir Model Object. Now, this actually then stores all the environment variables, the model information that we're going to use, so that next time if we want to come back to this, there's always a record of what was created before.
On behalf of the AWS OnAir team, we are honored that you named your model for us, Jim. Thank you very much.
All right. Then we'll go on to the create an endpoint configuration. This is basically a configuration for the endpoint itself, and the only thing that is usually different from one another is the instance type. In this case, we're going to use G6 16 large, which has one GPU in it. But in case customer has a larger model, they might need something larger than 16x large. Endpoint configuration is pretty straightforward. There are default values that we recommend. And then we will go ahead and actually create the endpoint name now. So we'll give it an endpoint name of live demo. And then we will kick off the endpoint creation using the configuration that we configured just above.
Okay.
This is going to take some time, so I'm not going to actually run it, but I did want to show that once we kick it off, then it actually shows up on the endpoint list as a live demo. But in the notebook, I'm going to cancel this, but this will still run at the background for the future purpose.
June, just for anybody who's new to all this, SageMaker endpoint, this is what I use to send prompts for inference, yes, to my model?
That is correct.
Okay.
Now, I do have an empty endpoint to share. So once the endpoint is created, note that it has the URL attached to it as well as the ARN. This is the resource and URL that will be used by customers to actually communicate with everything that's behind the endpoint. All right. Now, at this point, what we have is an empty endpoint with one instance up and running. And that instance is the G6 16x large that we set up. Now, what we're going to do is deploy the model object that we defined above into the instance by creating something called inference component. Inference component is a feature within SageMaker AI that allows the containers to understand how many GPUs and memories this specific model can consume from the instance. So in this case, we will define for the base model the number of GPU that the model will use as 1, and then the initial copy of the model as 1 as well. So if we have a large instance where there are multiple GPUs, if we put initial copy count as 2, what this will do is it will create 2 copies of the same model, 1 on each GPU. So this is how customers can control how many memory can be allocated to a certain model, or how many GPUs can be allocated to certain models. Now, if I run this, this will take some time as well. But notice on the on here that the live demo endpoint that we created above now actually has the base model creation in progress. So this will take about 5 minutes, so I wouldn't actually wait for it, but still, this shows how customers can actually validate when things are happening, and customer can actually go and look at the logs as well. Now, once this is done, you are actually running one base model on a instance where you can start to actually run the invocation. So for now,
no variance yet, but maybe we should jump to deploying that variance, because I know we are running short of time here. So I want to make sure we get to getting to those adapters and seeing how
Sure.
the variants get deployed.
Okay, cool. Then let me. Oops, let me actually switch my endpoint to the a demo endpoint that I already created, just so that we can speed up things. Give me 1 second.
Sure, no worries. We do appreciate the live demo. I think everybody does it. Adds a bit of credibility to it. It's really easy to have it recorded and scripted and go over and over until it's absolutely perfect. But honestly, this is what people want to see.
Yeah, thank you. All right, so let's move on to the installation of the LoRa adapter. Now, one prerequisite here is that the LoRa adapter needs to be already stored in S3. That's usually the most case after fine-tuning is completed, so a lot of customers would have those stored on the S3. One thing you have to do, though, is specify the location of that S3 as one of the variables so that we can use later. Here, what we're going to do is create a same inference component, but this time we're going to add something called specification that says base inference component name, and add the base component name that we created above. What this means is that here is an inference component, and this is actually associated with a base inference component. As soon as we define this way, the container understands that this inference component is meant for the LoRa adapter. And let me also put the endpoint names that we created above. And we also need to specify the artifact location of that inference component, which we already stored in the S3. And if we run this, it will go through the same process of creating the inference component and storing it into the instance that base model was already deployed to. Now, I already have this installed. So what customers will see after that is base model and adapter both installed into the instance. Now what we'll do is we'll start invoking on to the endpoint and see how the responses are different.
Yeah, it'd be great to see.
So here I'm just downloading a test data set from one of the open source data sets, and we're defining a prompt. What this does is the data set includes some of the financial reportings from different companies, and it's asking the models to summarize the financial reporting from that company. We also need to add the base component name here. The endpoint. So at the time of inferencing, customers need to specify which inference component they want to inference to. So in this case, because we are inferencing to the base model, I added the base model inference component name as a name.
Okay.
And then in the second case, I'm going to add the adapter name as the name of it, name of the inference component.
Okay, there we go.
All right, so both inferencing has been done, one on the base and then the other on the adapter. Now let's actually see how they are different.
Perfect.
So,
We're right about at time, so this would be perfect to show those results.
yep. So ground truth is the input data that went into the prompt, and then see that the first base model is responding with one type of narrative with a bit of a bullet point metrics. whereas the adaptive version is a full narrative version of the summary of the financial reporting. So this is how customers can actually compare and contrast between two different behaviors of a same model that were trained on different data sets.
Love
Now-
it, June. Unfortunately, we do have to run. I know there's always more to see, but we're going to leave that to you, the audience, to go out and try. We got some links, I'm sure, that we're going to be dropping in chat now for you to get just going right now with this feature. So, June, thank you so much for joining us. We really appreciate you taking us through all this, but we got to go. We'll see you soon.
Thanks for having me here.